Hello students, and welcome you all again to this video lecture series on chapter mechanical testing of metals. Up till now in non-destructive testing we have seen two types of non-destructive testing methods. First one visual testing and second dye penetrant testing. We have also seen the demonstration of dye penetrant testing. Now the third type of non-destructive testing method we are studying now is a magnetic particle test. So a magnetic particle test is a non-destructive testing method used for detecting the defects generally on the surface, as well as some amount of subsurface defects can also be detected by magnetic particle test. This test is fast and relatively easy to apply, and the part surface preparation is not as critical as for some other methods of NDT. The method is used to inspect a variety of products, forms such as casting, forging and weldings. Many different industries uses this magnetic particle inspection for determining the component's fitness for the use. Some examples of industries that are using this magnetic particle inspection are structural steel, automotive industries, petrochemical industries, then power generation, aerospace industries. Underwater inspection is another area where the magnetic particle inspection may be used to test the things that are as offshore structures and underwater pipelines. For this purpose we can use it in the underwater inspection also. So what is the basic principle of this magnetic particle test? Basically the magnetic flux leakage testing and visual testing are the two tests which are combined here in the magnetic particle test. The basic principle is similar to the magnetic flux leakage testing. So here we are considering electromagnet, that means by passing the electric current we are generating an electromagnetic flux or electromagnetic field inside the metal. Generally for using this magnetic particle test, that material must be a ferrous material so that electric current can be passed and it should be forming the magnetic field lines inside it. So similar to the bar of magnet, it has a magnetic field inside it, and around the magnet any place that a magnetic field of force exists or exits or enter inside the magnet is called as a poles. So generally that magnet is having two poles, north pole and south pole. Wherever the magnetic field lines enter inside that specimen is the south pole, and wherever this line exits, that is the north pole, that you can observe inside this diagram in the right hand. So here magnetic field lines has started from S pole, ended in the north pole. So whenever electric current has been passed through the specimen, those lines or magnetic field lines will get generated. Now if the iron particles are sprinkled on the surface to be detected for the crack, then the cracked component will generate or will attract all the particles which are sprinkled on the surface towards the crack. So as shown in that diagram, whenever the magnetic field lines has been generated inside the specimen, and that specimen is having a crack, and magnetic particles sprinkled over all the surface of that specimen are gathered towards the crack. This cluster of particle is much easier to see than the actual crack, and this is the basic of this magnetic particle test. Now through this magnetic particle test, as the magnetic field lines are parallel to the surface of this specimen, the cracks which are perpendicular to magnetic field lines can only be detected through this magnetic particle test, or the cracks which are at a 45 degree, less than 45 degree angle can also be detected. More than that angle we cannot detect the cracks. If suppose any crack is exactly longitudinal to the surface, then that crack cannot be detected by this magnetic particle test. This is one of the drawbacks of this test. As shown in that bottommost diagram, you can see the cracks at 45 degree that can be shown through the magnetic particle test. The crack which is exactly perpendicular to the length of that specimen can also be seen, but one crack which is a longitudinal crack, which is a exactly uh, exactly parallel to the magnetic field lines that cannot be shown. So here in that circular specimen, magnetic field lines are in the circular manner. So in the circular manner, if magnetic field lines are there, then the transverse crack cannot be shown, but the longitudinal crack can be shown. And in upper diagram, the magnetic field lines are exactly parallel to the surface. Then the vertical cracks can be detected by this. So to detect the cracks which are parallel to the specimen, you have to generate a perpendicular magnetic field so that defect can be detected. So what is the procedure for the carrying out this magnetic particle test? Generally it is carried out by the 5 steps. Firstly, you have to clean the surface to be tested. Sometimes on the specimen or in actual field you have to test the component for the any crack by using magnetic particle test. In that case, you need to clean the surface. If color is applied, some kind of coating is applied on the surface, then that you have to remove thoroughly. In second step, induce the magnetic field in the specimen. You have to induce the magnetic field by passing current. Magnetic field you have to induce firstly along the length and then perpendicular to length also, because you need to detect the cracks which are vertical as well as horizontal. So in that case you have to induce the magnetic field both way. In third step, you have to apply the magnetic particles to the specimen surface. Magnetic particles generally are the ion fillings. Same to the ion fillings, you have to apply the magnetic particles over the surface of the specimen. Fourthly, you have to view the surface looking for the particle grouping or clustering that are caused by the defects. So wherever defects are there, there will be gathering of all these particles, ion fillings or magnetic particles will be there, so that you can reveal that there is definitely a crack. Then lastly, you need to demagnetize this specimen and clean the specimen once again. This is also required. At the end, you need to demagnetize this specimen and you have to clean the surface. These are the 5 steps to be carried out for the magnetic particle test. The advantages of this test, we can find both surface and near subsurface defects. Now here only the surface crack is shown. If the crack is inside the surface, then also, but it should not be too much deeper, or only the near to subsurface defects can be detected by this method, because the magnetic field lines are not exactly horizontal or parallel to each other wherever defects are there. Due to that, there will be gathering of these magnetic particles at the crack surface. So the cracks which are on the surface and near to subsurface can also be detected by this method. This is also one of the advantage. Some inspection formats are extremely portable and low cost. These inspection format of magnetic particle test is portable and low cost. Rapid inspection and immediate results are there. Indicators are visible to the inspector directly on the specimen surface. It can detect the defects that are seen smeared over. Can inspect parts with the irregular shapes also, such as external splines, crankshafts, connecting rods can also be can also be inspected by using magnetic particle test for the defects. Some limitations are there. The specimen must be ferromagnetic. That means it must contain the iron content so that the current can be passed and it can be magnetized. Paint thickness should not be more than 0.005 inch. If it is more, then it should be removed for the inspection. Post cleaning and post demagnetization is required, and it is must. Maximum depth of sensitivity is typically 0.1 inch. So more than that, defects are less sensitive to be inspected. Alignment between the magnetic flux and defect is very important. It also needs a it also needs a it also needs a trained and experienced worker for that. So this is regarding the magnetic particle test, and in last lecture we have seen the liquid penetrant test or dye penetrant test. We'll just see in short the difference between these two tests, magnetic particle test and liquid penetrant test. And many times this difference is asked in exam. So firstly, in magnetic particle test source we are using a magnetic field, and here in liquid penetrant test we are using liquid penetrants. The principle in magnetic particle test is magnetic flux leakage, and here in liquid penetrant or dye penetrant test we are using a capillary action principle. Defects to be tested in magnetic particle test, we are detecting the defects on the surface and near to subsurface, whereas in liquid penetrant we are detecting the defects on the surface only. The material to be tested, all ferrous materials can be tested by magnetic particle test, and in liquid penetrant test we can test any kind of material apart from porous material such as ferrous and non-ferrous. Both type of materials can be tested by liquid penetrant test. Equipments used in magnetic particle test are magnet, electric current or a magnetic power. In liquid penetrant we are using cleaner, penetrant and developer. Cost of equipment, cost is very high in case of magnetic particle test, whereas in dye penetrant cost is relatively low. Operator, skilled operator or skilled worker is required in case of magnetic particle test, and it should have a very vast experience so that defects can easily be detected, whether it is on the surface or near to subsurface. In liquid penetrant test, semi-skilled worker is required. Sensitivity, so in magnetic particle test, sensitivity is more to detect the surface and subsurface defects, whereas sensitivity is more to evaluate only on the surface defects. Power consumption, magnetic particle test consumption of power is electricity, whereas no power is required in case of liquid or dye penetrant test. So these are some difference points between magnetic particle test and liquid penetrant or dye penetrant test. Thanks for watching. In next video we will be showing you the demonstration of the magnetic particle test. Thank you all.